This is Chapter 19, Module 3, ABO blood typing and the RH system. The learning objectives of this module are 1. Describe the ABO blood typing, and 2. Explain the basis for ABO and RH incompatibilities.
Red blood cells have surface antigens on their cell membrane. Antigens on the red blood cells signal to your body that the red blood cells are normal cells and should not be considered foreign. Foreign cells would be attacked by the body's natural immune system. These antigens allow the immune system to ignore the red blood cells rather than attack them. The absence or presence of these antigens determine your blood type. These antigens are integral proteins that are embedded in the red blood cell's membrane. There are at least 50 kinds of surface antigens, but 3 surface antigens are used to determine blood type in the ABO blood typing system. These 3 antigens are A, B, and RH, otherwise known as D. 4 blood types are formed based on these 3 antigens. Type A blood has only surface antigen A. Type B has only surface antigen B. Type AB has both A and B. Type O has neither A nor B. Individuals with these blood types are not distributed evenly throughout the world. For instance, the percentage of native South Americans with type O blood is 100%. The percentage of Caucasians in the U.S. with type O blood is 45%, while the percentage of native North Americans with type O is 79%. You can view the average values for various populations in a table in your textbook. The antigen RH, or D, is either present or absent on the red blood cells. If the RH antigen is present, the person is considered to be RH positive. If the RH antigen is absent, the person is considered to be RH negative. When the complete blood type is recorded, the term RH is usually omitted and a positive or negative sign is used. For example, a person's blood type would be recorded as O negative or O positive, or A negative or A positive, and so on. Just like the ABO typing, RH types differ by ethnic group and by region. For example, the percentage of RH positive blood types in native South Americans, native North Americans, and Australian Aborigines is 100%, whereas with U.S. Caucasians this percentage drops to 85%. Antigens on red blood cells are given the name agglutinogens. Your plasma contains antibodies that will defend your red blood cells against foreign blood. When these antibodies attack, the foreign cells will clump together, which is called agglutination. If you have type A blood, your plasma contains anti-B antibodies, which will attack type B surface antigens if they appear. If you have type A blood, your plasma contains anti-B antibodies. If you have type B blood, your plasma contains anti-A antibodies. For a person with type O, their plasma contains both anti-A and anti-B antibodies. And for a person with type AB, their plasma contains neither anti-A nor anti-B antibodies. The presence of these antibodies is genetically determined, and they are present throughout life, regardless of whether the individual has ever been exposed to foreign red blood cells or not. In contrast, the plasma of an RH negative individual does not contain anti-RH antibodies. These antibodies in the plasma are present only if the individual has been exposed to the RH antigen. Such exposure can occur accidentally during a transfusion, but it can also accompany a seemingly normal pregnancy involving an RH negative mother and an RH positive fetus. When an antibody meets its specific surface antigen, the red blood cells agglutinate and may hemolyze or burst. This reaction is called a cross reaction. For instance, an anti-A antibody that encounters A surface antigens will cause the red blood cells bearing the surface antigens to clump or break up. These clumps can plug small blood vessels in the kidneys, lungs, heart, or brain, damaging or destroying affected tissues. These cross reactions or transfusion reactions can be prevented by ensuring that the blood types of the donor and the blood types of the recipient are compatible. The surface antigens on the donor's cells are more important in determining compatibility than the antibodies in the donor's plasma. This is because the donated plasma is diluted quickly through mixing with the large plasma volume of the recipient. Also, to minimize the risk of a cross-reaction, packed red blood cells with minimal plasma volume will be transfused. A compatibility test is usually performed prior to any transfusion. To test a person's blood type, drops of blood will be mixed with the antibodies in separate solutions. One drop of blood will be mixed with anti-A antibodies, another drop of blood from the same individual will be mixed with the anti-B antibodies, and yet another drop from the same individual will be mixed with the anti-RH or anti-D antibodies. Any cross reactions are then recorded. If the individual's blood clumps when exposed to both anti-A and the anti-B antibodies, then this individual has type AB blood. If no reactions occur after exposure, the person must have type O blood because there are no surface antigens for the antibodies to react with. The presence or absence of the Rh surface antigen is also noted, and the individual is classified as Rh positive if the anti-Rh antibodies cause clumping, and Rh negative if there was no response to the anti-Rh antibodies. Standard blood typing can be completed in a few minutes. However, in emergency situations when a person doesn't have a few minutes, type O, preferably type O negative, will be administered. Type O blood has no surface antigens and so will not react to any of the antibodies in the recipient's plasma. Type O blood is then considered a universal donor. Type AB individuals were once called universal recipients because their blood contains no antibodies in the plasma and therefore they would be able to receive any blood type. Now, because of the adequate supply of blood donors, a type AB individual will receive type AB blood. It is possible to strip the antigens off a red blood cell to create type O blood, but this is very expensive and time-consuming. Also, even when type O blood is donated, there are still many other antigens other than A or B on the red blood cells that could cause a reaction, so it is important to have a compatibility test performed prior to administering. Blood types are inherited, so blood tests are used as paternity tests and in crime detection. Blood tests cannot prove paternity, but it can rule out paternity of an individual. For example, it is impossible for an adult with type AB blood to be the parent of an infant with type O blood. Mostly, DNA testing has replaced blood typing testing since DNA testing is 100% accurate. When a mother is Rh negative and her fetal baby is Rh positive, this will cause a disorder created by a cross-reaction between the mother's blood and the baby's blood. During pregnancy, the fetal baby and the maternal vascular systems are closely intertwined. The mother's antibodies may cross the placenta, attacking and destroying fetal red blood cells. This will result in a condition called hemolytic disease of the newborn, or HDN, which can be dangerous to the fetal baby. Problems in a first pregnancy seldom occur with an Rh negative mom and an Rh positive fetal baby. This is because very few fetal cells enter the maternal circulation, and so the mother's immune system hasn't yet developed the anti-Rh antibodies. Remember, if the mother is Rh negative, she will only develop the anti-Rh antibodies once her blood is exposed to the Rh antigens. Exposure to fetal red blood cell antigens occurs during delivery, when bleeding takes place at the placenta and the uterus. Mom's blood mixes with baby's blood, stimulating the mother's immune system to produce anti-Rh antibodies, leading to sensitization. This sensitization usually occurs within 6 months of delivery. Because the anti-Rh antibodies are not produced until after delivery, the first infant is not affected. During the second pregnancy, however, the mother, who is Rh negative, is now sensitized to the Rh antigens, and she carries the anti-Rh antibodies in her blood. During her second pregnancy, these antibodies are small enough to cross the placenta and enter the baby's bloodstream. These antibodies destroy the baby's red blood cells by agglutination, and this produces a dangerous anemia. The immature red blood cells in the fetus will leave the bone marrow prematurely to help with the anemic, oxygen-deprived tissues of the baby. Without treatment, the baby will die before delivery or shortly after. This can be prevented by having the mother having injections of Arogam in weeks 26 to 28 of pregnancy and during and after delivery. These antibodies will destroy the baby's red blood cells that cross the placenta before they can stimulate the mom from creating anti-Rh antibodies on her own. This is a simple procedure and has almost entirely eliminated infant mortality due to Rh incompatibilities.
This ends Chapter 19, Module 3, ABO blood typing and the Rh system.